差点忘记。OK。A few of the string is numbers of distinct characters from the string. For example, ABBCA is 3 because 3 is distinct. Appeal. Okay. Total appeal with sole substring. Oh, got an idea. So I have a brute force approach is brute force approach is n-squared. This is idea. And the course to find or substring of S cal appeal over substring of S. Appeal is the numbers of distinct characters. So say this will be 1, 2, sync. I have no idea. Substring. So it means you need to enumerate, but is this very, very slow? Where should we do that? We have A here. We have B. We also have 3. Still a 2. Okay, still a 2, still a 2, still 1. How do you think? Okay, let's just do brute force approach to see what patterns we can observe. So in this to now the question is how to optimize. Okay, I want to do that problem. Given the integer numbers, the kp numbers, they can separate at most k element divisible by p. Swan numbers to say to be distinct if there are different lengths or exists one equal. Wow, what it means. Numbers separate at most k element divisible. Number distinct separate element 0 and 3 and 4 are divisible by this. At most 2, 2, 2, 3, 2, 3, 3, 2, 3, 3, divisible. by 2. Should not be counted because it has three elements that are divisible. Oh, okay, got an idea. I have a brute force approach. Oh, yeah, you can use the brute force because n is directly smaller. Yeah. How to do it? But you need to calculate the distinct subarray. So 2, 2, 2 is the same. Yeah, 2 to 2 is the same. How to avoid distinct element? Distinct subarray. Distinct subarray. How to do that? You know, distinct subarray. 2, 2, 3, 2, 3, 2, 3. Starting from this. Okay. Well, this problem just subarray today. Subarray problem. I don't like it, but yeah, it's interesting. Minimal consecutive cards pick up. You given about cards represent a value. The ice pairs cards are matching if the cards have the same value. Consecutive card pick are the main matching most pick. If it is impossible, have matching card return active 1. We can choose 4 and 4, 3 and 3. 3, 4, 2, 3. A pair of the cards matching if the cards have same value. Consecutive card, you have to pick R to have a pair of matching card among the picking card. We can pick a card. You have a matching card. Matching card means note that picking a card is also optimal. Wait, I don't understand. Oh, you have a pair of matching card. Okay, I got the idea. So okay, I got the idea. First, calculate the minimum length that can make only one matching pairs. Okay, what is the idea? Minimal length can only make one matching pair. Okay. So if we do from left to right, we say, okay, we don't have this. You know that there's I want to use this. Math. This is record the number of frequency. Use 2-pointer. sliding window approach. Cards are at 1. Yeah, so use 2 pointer, sliding window. Remove the digit from the number to maximally result. Positive integers array digit. Exactly 1. A character. Okay, this is length is 1 and numbers represent the positive integers. Result string after removing exactly 1 occurrence digit from such that by results decimal is maximal. Okay. That is 1. Actually, we just do one last digit. Okay, so what is the goal? Is remove 1 digit to make number largest. Do it reverse from the right. Just find about number. Okay, we can use indexes. Number find last 4th digit. Zero to index. Yeah, we can do this. From the right, actually is used to find the last or occurrence. Oh, we don't know it. Wait, we don't start it from this. Just ignore this. Yeah, ignore the index because we don't really need this subtrain about. Oh wait. Greedy approach. Wait, this is. We have 2 1 here. Actually, remove first one will make them largest. Okay. Okay, I don't want to use this. Yeah. Greedy. Let's just fail. Still be greedy because we have the increasing. This is increasing, we just remove the first element. If this is not increasing, we don't have increasing element. It means that we don't make that largest. Okay. We don't make that largest, so we remove the last element. For example, let's say 5, 6, 5. If we always remove the first digit, we have sure. Wait. Is that correct? My first one? For example, say this is 3, 2, 1, 3. If we remove 3, actually, let's not remove the largest element here. So you need to do that is if the only case is decreasing, so if number I is greater than number I plus 1. We found it. Just found it. Otherwise, we don't found it. Just don't found it. That element is going to be 5, 1. Yeah, this should be true. Find the last element of the digit, and if we find out that they have increasing, they can make that increasing, we find string. Okay, waste so much time. It's too problem to figure out how to do this. Fine. Numbers distinct subarray that have at most k elements divisible by p. What means distinct? So we need to find number of distinct subarrays such that have at most k element in array subarray. Number of distinct subarrays such that have at most k elements in subarray, k elements in subarray that divisible by p. Yeah, what's idea? We can use the set to do that. Hash will be very big. We cannot use this. No, this is 3, 2. Then this is 4. Oh wait, I have idea. So idea is 2 pointer. We still calculate it. If from current position to extend is greater than, okay, we just subtract the just shrink L. So we have the current positions here. From each position, the time complexity may be linear. N square, yeah. The idea is that for each position, we'll try to extend. Okay. Say this case, we say 2, 3, 3, 2. So after we calculate that in the next one, 3, yeah, 3, yes, 2, yes. Okay, if this is the same, of a previous number. This may need to calculate it. Don't need to calculate it. Yeah. So from each position. Wait a moment. Try to figure out that how to avoid duplicate. So for example, let's say this. We calculate the numbers of the element that is wait. It's too a noise. Okay. Yeah. How to avoid duplicate? So lens 1, lens 2, lens 3, lens 4 until the lens k. Yeah, I think this means if we both use the subarray, calculate subarray, that can be n square. You want to give it a try? You want to give it a try, Brufos? Try Brufos? First, the question is how to avoid duplicate. How to avoid duplicate. This is the question I want to think about this. I don't have a very simple idea to do that, but if we can just say, okay, 3 we know, 2, let's just try to do how many number? 1, 2, 3, 4. Okay. Actually, you can see is divisible. So yeah, I want to try brute force. Maybe you can give it a try. Numbers J here. Zero. Okay. Count this greater than k, we break it. What is kind complexity? Yeah, give you a try. What? Is this a step? Wow, what the fuck? Okay. So I just do brute force. Interesting. Now question is how to optimize. This is the question. How to optimize this? Suppose we have the distinct element here. Say, okay, this is 1, this is 2, this is still 2, this is 3, this is... Okay. Suppose What's the idea? What is the idea? It's 1, 2, 3. Okay, I got it. 1, 2, 1, 1, 2, 3. Okay, I can figure out that for each element, for each index position, we just try to, okay, so this position, we just find out that, okay, numbers of the appeal from the last is going to be 2. Yeah, think about this. Okay, and weak about this problem. This type of questions are really weak. It's not a hard problem, but you need to figure out some pattern is going to be. There must be a pattern here. We have the index here, but I have currently no idea. If we just do stupid approaches that, okay, and appeal. What is appeal? Means if this is not visit, right? So we say appeal. We can use the set or something. We can do that, but yeah, that's not a good. That's not a good questions. Okay. Appeal. Say we have appeal. So for example, if we're starting from this position, we can say, okay, 1, 2, 3, 3. From this position, 1, 1, 1, 1, 2. Actually, it's increasing, right? So we say, you can see the pattern. Is from this index, we say 1, 2, 2, 3, 3. From this index, we say 1, 1, 2, 2. Wait, I can figure out something that is 1, 2, 3. Wait, this is 1, 1, 2, 3. This is 1, 2. This is 1. Wait, can you figure out something like this? 1, 2, 2, 3, 3. You can see what is the pattern. What is the pattern? What is the pattern? What is the pattern here? This how many numbers of substring that have the 3? This index. How many? We have 3. You see the pattern? Increasing, right? The appeal is increasing. Can you just find out that I can figure out it. Wait, I can find an idea. Okay, I got an idea. Because appeal maximum is 26, so we can say binary search the appeal. Remember? Yeah. For example, say for this index, we just try to binary search 1, then calculate 2, and calculate 3 until the 26. We want to binary search that k is going to be 0, k is 25, 26. Binary search the length. Lower bound and upper bound. Yeah, but the question is how to how to calculate it. This is 1. We know this is 1. Know that. How to do this? Binary search the length. Appeal. Yeah, we can search 1. Length is 1 is 1, 2 is 2, 3 is 3. 2 is 2. But the question is, when you construct this, how to change the value to the next? I think this is a problem. You need to figure out that. So we will change the old value between the current to the next. Yeah. Yeah. Stop. Say calculate the sum. range update. So yeah, another idea is we update the range by this. We know this will be subtract 1 until this. Yeah, we can use a count. Okay, I can figure out that. Okay, so I have some idea. So now what we want to do is give you we just okay, actually your answers is going to be 5 as 11, and this will be 8, right? This will be 7. Wait, this will be 7 because we subtract this range and subtract 1. So we subtract 1. So we subtract a range and subtract the current position. So we subtract a range. Range is 0. Subtract 1. We subtract range. If we don't have that element, we just subtract all. So -3, -1, -0, minus. Okay, so I can got idea. So if we calculate the first element, we will say this will okay. I can figure out it. -3 -1. Yeah, I can figure out this. So this is 9. Wait, this is 6. Subtract 2. Okay, I can got the answer. So first I want to calculate the first appeal of each element. Let's say the total. We can use set appeal. Will insert about SI. Total will add about appeal size. Yeah, can figure out it. So we just calculate a range between. So we still need the index here. Side here, and this should be work. Yeah, record index. We just calculate. Okay, what is the net to this distance? How many number in this between? Because this O will always decrease by 1. Yeah, total. First time. First time. Yeah. And after that, okay, now the answer is going to be total. The resource is total. First time we do, and yeah, from each position, let's just try to erase this. So we say index numbers I. Size, otherwise it's empty, so we'll minus the old value. So we minus about the first, right? So we say, okay, so total will such a 1 total, because erase the current position, erased by 1. And what is the distance between this? It's going to be J is going to be front. So total will subtract the distance. Otherwise, this we will subtract that numbers of this range. So we say yeah, that's the idea. Wait. What are we doing now? Just runtime error. Why? Push. Actually, we never pop this. We pop out A. Why? What? Wait a moment. Because we have what? null pointer. Runtime error. Index will push. String. Oh, 26. Forgot to do that. Yeah, this math problem. This math problem. Okay. Math problem. Wow. Spend too much time. Yeah. Wow. Spend too much time. What? Okay, seems that the record is not updated. Okay, doesn't matter. Okay. Yeah, just okay. So first problem is very greedy. You just find out that okay, want to remove a digit 3 and exactly 1. You need to remove exactly 1, and you want to make the number is maximum. You want to make the number is maximum. So what is the idea? Idea is that okay, this is fail. We don't, because if we just reverse the right position, actually it's not a greater, right? It's not a greatest. It's not a maximal decimal number, because for example, it's 1 2 3 1. If you have an increasing, you just remove the first increasing, make the increasing element. So we want to find out that. So the idea is find the first increasing, and the number is digit. Yeah. So if we don't find this condition, we just find the last of element and just erase this. Yeah, that's a problem. Okay, and question number 2. This problem is you want to find out what you can match in the element ones. What it means matching? Matching means that they have the same value. So you want to find out that what is the minimum length of this has exactly 1 matching card in this segment. For example, this is the minimum segment that have 1 matching pairs, because actually you can observe answers, minimum answers is 2, because we can never smaller than 2 and have 2 value that can be matching. So idea is we can use additional array to record frequency. Actually, we don't need to do this. We just use a set. We also can do that. So we add about a map, and we see okay, if the current value is going to be 2, we recall the minimum length, and we try to shrink a range to until the card is smaller than 1. Why this can work? Because if this is 2, we don't shrink then. That means that okay, we still extend the range, but you can easily to observe that this range is always not produce the greater value, right? So yeah, so we find out that we must shrink a range. We must shrink a range. So that's the problem. And okay, this problem Q3 and the Q4 I think is a little do very bad, but this problem I think is very hard. But you can see the numbers I is more than 100, and this problem is you need to find the subarray that is distinct, and the subarray that must be at most k elements divisible by p. So maybe we can do 0 element divisible by p, 1 element divisible by p until the k minus 1 divisible by p. So we just try the brute force approach. But yeah, the idea is why brute force can work, because you can see that, okay, what is time complexity? You know the set. Okay, it's n and n squared, and this what is object is going to be it's going to be n cubed, because we push back the ray and we compare ray. Actually compare ray needs the length of this compares. So at most log compare. So it's actually I think is this single time complexity is going to be this. Yeah. Such a bad idea, but it can work. Yeah, it can work because the range is relatively small. Such a bad idea. Yeah. Or you can hash to the string. You can figure out that we'll have 3 digits, right? So the length of the digit will always be length of the digit. If we hash to the string, the length of the digit is length of the digit is maximum. It's going to be product. Yeah. So is it workable? Yeah, I don't think so, but currently I don't have a better idea to solve this problem. Yeah, I don't have a better idea. And this problem is a math problem. Actually, it's not hard. Because you can write down that formula that means okay, let's say this problem. Let's say the PO means that the distinct character are found in the string. So we now found that the total appeal of substring, and you can observe that appeal is always be increasing. For example, this is appeal is 28 because we have length 1 has this, length 2 have this, length 3, length 4, length 5, and why this is how to do that. The brute force approach is that, okay, we can just use some square and calculate each substring. We just calculate the PO, but this will be TOE. How to do that? Consider that we just type down the appeal of the number and we'll observe a change. You can see the change. This range will decrease by 1, right? Wait. This range will decreasing by 1. So we can calculate the sum and we just subtract the range element, subtract 3 and subtract the current element. So you can see this is the idea. If we don't have the next character, we just subtract all the value because we don't have we must make the appeal, all suffix appeal of the appeal will decrease by 1. So we do the first time. That means this is on linear, and for each we just we pop out this and we calculate that. What is the next? We just calculate the distance. We calculate distance here. In total, subtract 1 because we because we shrink subtract a, so the total number will decrease by 1 because we found this, and we see what is the total change? Total will change this, and we add all the value. Last idea, time complexity will be linear. Yeah, that's problem 4. Still not updated leaderboard. Okay. Oh, pretty good. But I spent too much time to figure out these two problems, and this question number 3 is the noise. I don't, it's occur. Yeah, I don't like the question number 3. Yeah, but I think they have another idea can do that. Yeah. Okay, that's it.